shall we? How's it going, everyone? Welcome. And we are Gonzalez. So let's take a look now at the chapter 5 and chapter 6 from this series of book of You Don't Know GS Yet. To in this book to explore about the scope and closures and the case here for not only scope but also is for the different scope that we can have in our language that is provided by a ECMAScript, and that is the function, the block, and ultimately is the global scope, which is each one of those scope is the place where now we can make all of these different variables that can hit that act as a containers to hail values that it can be primitive, so far so good, uh, whether it's a string, a number, boolean, big int, any kind of undefined, null and undefined, as well as symbol, and also is objects, which is now it can be is a collections of objects, or a key map objects, or even now set of instructions like a function. And when we now look at the functions, that the function's definition and the function expression, especially when you define a function, you are creating now a scope, or JavaScript is creating a scope for this syntax directed operation, which is a technical term that is using. In any case, is for any of these reserved keywords. In our case, the function, well, is going to now trigger an algorithm. And this algorithm is not only to create this function, or not only to create this scope, but also is to create the lexical scope or the variables as well, right? As well as the execution context. To evaluate is the code inside of this function, aka the declarations or the statements. And the difference the declaration and the statement is that the declaration is where you write to illustrate or to say JavaScript, hey, this is a definition, that this definition can be a variable, we can take a look at that. These definitions, if we look at this, we're talking about is a statement, exactly. So this is statements and declarations, all right, but this is statement that actually now produce a value usually, all right. It can be now is a block statement, which is something that we're going to see also as well. So it can be is a variable statement, all right. It can be also an empty statement, so only the column. It can be an expression statement, that this is a statement actually produce is a value expression statement. It can be if a statement, breakable statement, continue, return, with statement, label, throw, try, and debugger statement. But again, this is all of the statement that you can define inside of your functions, that anytime that you do that, you create now is a function, or you create now a scope, and that declaration that can be hostable. So for example, functions declarations, so functions generator, async function, and async generators. Class is another hostable declaration as well as the lexical declaration, which is let and cons. All right. So I'm just describing is this because this is what the possible values that a variable can have. And since we can have now variable, since we can hold functions inside of a values, instead of a, since we can hold functions inside of a variable, and the scope structure that determine is how these different scope relate to each other, the block, the functions, and the variables. And all of this happening is before our code is executed, not because I say so, it's because when we evaluate is the behavior, the observable behavior in JavaScript, instead of acting like a scripting language, so it's going to line by line to evaluate that. It now has a step before execution, pretty much like a compiler, not when it comes to distribute it is software, but also when it comes to analyze that source of text. So this analysis, it is based on how it responds to certain syntax errors, some early errors, as well as hosting, these hostable declarations. So since we also look at the important to understand that inside of these hostable declarations that I mentioned is that it can be is a function declaration, it can be a class declaration, and a lexical declaration. So these declarations, for example, like the functions, where now they're going to, or this hostable, okay, what it means is that they're going to put now those variables at the top of that scope, all right, or those declarations at the top of the scope, and depend of the declaration, whether it's a function or a var, the algorithm that JavaScript is going to use to determine not only how what to do with the hosting, but what the values are going to be initialized. And that is, in the case of var, is going to be initialized with undefined, and then the function is with the value of that function, with the function in itself, with a set of instructions in there. So since we have this, right, we have also another declarations that can be host, all right, pretty much like lexical declarations, let and cons. When we evaluate now is things like or when we ask questions like variables, so for example is with let and cons and how they behave, they unfortunately when the definition of the functions appear past before a statement, all right, there's a question is that how will any reference before the declarations will be or behave, right? And that is entering is a certain concept here. So for example, is, well, that if that happens, all right, because at the end of the day, these hostable declarations, so for example, like class declarations, in particular is the lexical declaration, like let and cons, okay, like this. Let me see if they actually mention anything related to that. Variable statements, let and cons declaration. There you got it. Okay. And here is what it's describing is this particular behavior. All right. So let and cons declaration define variables that are scoped to the running execution context and lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable lexical binding is evaluated. So this is known as the temporal dead zone. In other words, it's just saying that if you define now variables, or if you declare variables in the you, for example, with let and cons, you try to access that before it is definition, you can access to that. So the variable has been hosted, but it's not reachable. And this is known as the temporal dead zone. And there is a justification of why we have is this temporal dead zone, which is, well, here we do this is in the case of cons, all right, because if you try to initialize, if we use the sense here to say, hey, a count is only a unique value, but if you hoist that in a block scope and then initialize to undefined, and then after that comes the statement, then you assign a value. That's something that is not how constant works. All right. So this is why they prefer the JavaScript to the TC39 actually prefer to set is this cont with this behavior, which that makes quite sense, right? But also they added to the let, and that's when things can kind of fell apart a little bit. But the TLDR of this is that let and cons, they are both hosting, and it is interesting because you may wonder, how do you know that they are hosted? Okay. Well, a good example is this: when you via the shadowing, aka when variables with the same identifiers are declared in different nested scopes, that's when shadowing occurs. For example, you have var, you have now is student name, okay, without initializing anything here, and then down below, I was going to initialize here with some value here, say, hey, this would be is a boolean. All right, and then you have now a block scope, all right, to say, hey, well, I just want to access to the student dot name, which is a boolean, right? Similar for if I let it define is now the new student, all right, but in this case with let, all right, and then I try to access to console log a student name. So what will be the so if shadowing happens, all right, which shadowing is something that happened here. For example, if you call here to say, hey, greeting, all right, and if you now say something like this, and if you try to call greeting, all right, it will throw is a reference error. It say, hey, cannot access student before initialization. However, with other variables, so for example, if we use now var to redeclare this student, to say now Arthur, okay, Arthur, um, as you can see here, it say, hey, initially author is undefined because var here is, you see the logic say, hey, well, since we are now in this function scope, and any in var our function scope or behave in this function scope, and it is behavior is that is going to be initialized with undefined, so it makes a lot of sense to access to this. All right. However, if for some reason we try to say this as it is, all right, in this case we are now accessing to the proper outside variables here. This is known as the scoping. But the point of this is that this behavior that we see here, known as shadowing or mid-shadowing, this is something that, hey, this behave as expected. It follow our instinct. But when we do that with let, or even inside of this, okay, if we do that with let, for example, exactly. So if we do that with let, for example, author, and as you get, oh, because I trigger that, I don't need to do this. So for example is this, as you can see here, var allows redeclarations as well as reassignment of its new values. And because the TC39 recognize that this behavior is kind of confusing, and also as you can see, this is known as mid-shadowing. So hey, you can now have access to the outer scope in this block, but not in the let, because now the behavior changed here. So the point of this is that this behaviors where you can reach the variables that is before it is declaration is known as the temporal dead zones, and it is called temporal not because it is in the position where it was defined, but it's because it's when it is evaluated. And a good example of this is for example with the function that we defined previously, right? For example, like this, and then we say something like this. Greeting. All right. So if we call now greeting here, because this declaration are going to be hosted with its value, since this is a function, we can now call that, and because at that moment of execution, it tried to access to student name, it will ask in this, the compiler will ask in this moment, hey, do we have now a student name? No, we don't. In this context, okay, let me see if I have that in the outer scope. And no, we don't have it. So student name will throw now is a reference error, as you can see here, right? So again, it's saying the same before initialization. So, but the point here is this actually now throw is an error here, okay? To try to access that student name, and this here is doing in this particular context because we're using is var, right? We're using is let. If we're using var, all right, it will actually if we're using var here, that's right. If we're using var, the initial value will be now is undefined, all right, because it's not hosting. Remember, this identifier, since now it is being used as student with var, is actually passing and is hosting this with the var behavior. But if we, for example, do this, we can now have access to that identifier and print that as earlier. That's the the logic of this time to that to this temporal dead zone. This is the reasoning behind that. We also look at how now the let and cons behave in looping conditions, all right, and how unfortunately now cons for traditional for loops, you can use that because it will now reassign its values on every iteration when it enter into that scope, which is of course not allowed. Uh, in a case or the reason why, for example, we have this hosting mechanism, is because we can define is our executable code first, and our for functions the executable code first and the definition later, and conveniently use var when we need when we see fit in our code. But I do think that the main case of this is that defining is this functions here. That's the main use case of this, or the reason why we have now hosting in the language. So to improve the readability of the code, so you define all of the executable code first, and then later on the declarations here. So according to this logic, it makes sense right now to organize our code in this way. So that was a lot to take in. All right, that was a lot to take in. Absolutely, absolutely. So this is we also look at yes at the this only works for this hosting only works for functions declarations or for certain declaration, but not for expressions, aka when you define is a function or a hostable declaration, whether it's a function, let in cons you can define that as a value, but functions declaration and class declarations, if you define that as a value that if you define that as as a value of a variable, that is not hosting. Mm-hmm. That's very interesting. It's very interesting. Uh, in order to at least understand is the reasoning behind this. So, and the thing with TDC, which is this particular concept with the temporal dead zone, is that with let and count, since this thing is visible, that's why this concept is way much more straightforward, because all of those definitions, hostable definitions, actually has indeed is this temporal dead zone. The thing here is that with let and count, that behavior is observable, unlike var in functions. Mm-hmm. So working with variable has much more nuance than it seems at first glance. And working with variables is one of the most important things that we have to do in programming here. And I do find that that's quite interesting. Absolutely. Absolutely. Mm. Mm. Sorry. My bad. Mm-hmm. Okay. Okay. And not only in this programming language, but in any programming languages. Okay. Good. 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 Yeah, oh, absolutely. So working with variable has a much more nuance than it seems at first glance. My question is hosting happens in other programming language or is just in this scripted language? Hosting and redeclaration and temporal TDC are common source of confusion for developers. Mhm. Especially those who have worked in other language before coming to JavaScript. Before the question is, diggy diggy. In the case of iOS, right? iOS does Swift programming programming language, except the Swift programming language has hosting. Okay, has hosting. Font has hosting. Uh, and temporal dead zone like JavaScript. Oh, because this is a compile, exactly. Because this is a compile language. Of course, of course. Any compiler language will not have this kind of behaviors. hmm Swift approach is simple and safer. What you see is what you get. The compilers and for the variables are declared before use, eliminating an entire class of bugs that occur in JavaScript. mm-hmm. Mm-hmm. Swift scoping is straightforward and predictable. It's because this is now a compiler language. Yeah, because it is a because it is a compile language, and that makes sense. But what about scripting? But what about other scripting languages like Python? Python also doesn't have hosting. Interesting. But it has interesting query that can surprise people. No hosting. Okay, variable must be assigned before use, and you will get a runtime error, name error, if you try to access them too early. But Python has a weird scope quirk. Python does scope analysis when it parses your code, and it sees an assignment anywhere. Okay, and if it sees an assignment anywhere in a function, it treats that variables as local to that function, even before the assignment. Unbound local error, local variable x, reference before assignment. Because of this assignment, Python treats x as local throughout the function. This isn't hosting, but it can feel similar. Python saw x later in the function Python saw X later in the function and decide X is local for the entire scope. Mm-hmm. Mm-hmm. So what about other scripted scripting languages? Ruby doesn't have hosting. PHP kind of has hosting for function but not variables. Perl no hosting. Lua no hosting. And Bash kind of. You can reference variables before assignment. They are just empty. Interesting. The trend, most scripting language avoid JavaScript style hosting. Many are permissive about undefined variables, treating them as null, nil, or empty, rather than throwing errors immediately. JavaScript hosting is really the outlier. But also PHP has now functions. Okay. That's a very interesting things to know about this. So compiler language, of course, makes sense that they don't have any hosting here. All right. Okay. But scripting language, for example, like PHP, has now hosting for functions only, but not for variables. And this subtle distinction I do think is quite interesting here. Mm-hmm. 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 Let me do something here, because I do want is to make a reality check here with this. Why is not showing that? I think there's some. Oh my god, you are not allowing me to do this? Why you are not allowing me to paste anything here? You not only go back. No. I don't know what's wrong with you, but you are very. Look at you. You're not even allowing me to. Okay. I do. I see. I see. I see. I see. Let me hit the break here. And here we are. Okay, so we asked now I wrote a prompt here to avoid any hallucination. And if you hallucinate, please tell me that you do that. And he's describing is this. So based on my knowledge base, no mainstream scripting language has both hosting and temporal dead zone. Hosted initializes undefined and let them counts hosted but remain in the temporal dead zone until declaration. Function declarations are fully hosted with definition. In other languages approaches like Python, they don't have hosting. And has function level scope but not TDC concept. Ruby, no hostings or TDC. Variables come into existence when first assigned. And PHP functions and class declarations are available throughout their scope, but variable hosting doesn't work like JavaScript. and in Lua, no hosting or TDC in the JavaScript sense. And inference. Some languages have partial similarities like PHP functions availability, but none replicate JavaScript specific hosting and TDC combination for both variables and functions. So the thing here is that PHP has hosting for functions only. That is quite interesting to know about it. Absolutely. Okay. So this is now the chapter 5 here. All right. So hosting is generally cited as an explicit mechanism of the JavaScript engine, but it's really more a metaphor to describe the various ways JavaScript handles variables declaration during compilation. But even as a metaphor, hosting offers useful structure for thinking about the life cycle of a variable. When it is created, when it is available to use, and when it goes away. Declarations and redeclaration of variables tend to cause confusion when thought of a runtime operation. But as you shift to compile time thinking for this operation, that certain declarations now happens before the code is executed. For example, functions, variables, let, and cons, and it is redeclarations. The quirk and shadows diminish. The TDC temporal dead zone error is strange and frustrating when encountered. Fortunately, TDC is relatively straightforward to avoid if you're always careful to place let and cons declaration at the top of any scope. As you successfully navigate these twists and turns of a variable, the next chapter will lay out the factors that guide our decisions to place our declaration in various scopes, especially nested scope. And as we move on now to the next chapter, which is limiting scope exposure. So far we has been explaining the mechanism of how scope and variables work. So how scopes exactly? We have so far looked at the mechanism and explain how scope and variables works, right? With that foundation firmly in place, our attention's raised to a higher level of thinking, decisions, and okay. So with that low level, or with that foundations of the mechanism between the scope and the variables, right? It's now the time to look at things at a higher level. Uh, Decisions and patterns we apply across the whole programs. To begin, we are going to look at how and why we should be using different levels of scope, functions, and blocks to organize our programs, variables, specifically to reduce scope over exposure, the least exposure. So it makes sense that functions define their own scope. But why do we need blocks to create scopes as well? Software engineering articulates a fundamental discipline typically applied to software security called the principle of least privilege. I said, but why do we need blocks to create scope as well? And a variation of this principle that applies to our current discussion is typically labeled as least exposure. Principle of least privilege express a defensive posture to software architecture. Component of the system should be designed to function with least privilege, least access, and least exposure. Okay. Based on these fundamentals. And it makes sense. I'm gonna expose you on the necessary data that you need to go with. And this is go now from the security aspect. So, for example, a zero trust policy, and so on and so forth. If each piece is connected with minimum necessary capabilities, the overall system is stronger from a security standpoint because a compromise or failure of one piece has minimized impact on the rest of the system. If POLP focus on system level component design, the POL exposure variant focus on low level. Okay. Principle of okay. If principle of least privilege focus on system level design, principle of least exposure variant focus on a lower level. We'll apply it to how scope interact with each other. In the following poll, what do we want to minimize exposure of? Example, principle of least exposure. What do we want to minimize exposure? What do we want to minimize exposure? Simple, the variables register in each scope. Think of this way, why shouldn't you just place all the variables of your programs out of the global scope? That probably immediately feels like a bad idea, but it's worth considering why that is. First, because the name collision. The name collision. When a variable used by one part of the program are exposed to another part of the program via scopes, there are three main hazards that often arise. Naming collision is one of them. If you use a commonly useful variable function's name in two different parts of the program, but the identifier comes from one shared scope, like global scope, the name collisions occur, and it is very likely that bugs will occur as one of part use of the variable functions in a way that other part doesn't expect. So for example, imagine if all of your loop use a single global I index variable, and then it happened that one loop in a function is running during an iteration of a loop from another function, and now the shared I variable get an unexpected value. The other is unexpected behaviors. If you expose variable functions whose uses is otherwise private to a piece of the program, it allows other developers to use them, other models to have access to, in ways you didn't intend, which can violate expected behaviors and cause bugs. For example, if your part of the program assumes an array contains all numbers, but someone else code access and modifies the array to include booleans and strings, your code may be misbehaved in unexpected ways. Worse, exposure of private details invites those with malintent or ill intent. Exposures of private details invite those with ill intent to try to work around limitations you have imposed, to do things with your part of the software that shouldn't be allowed. Unintended dependencies. If you expose variables functions unnecessary, it invites other developers to use and depends on those otherwise private pieces. While that doesn't break your programs today, it creates a refactoring hazard in the future. Because now you cannot as easily refactor the variables or functions without potentially breaking other part of the software that you don't control. So for example, if your code relies on an array of numbers and you later decide it's better to use some other data structure instead of an array, you now must take on the liability of adjusting other affected part of the software. But all of this is the justification of why we are looking at this high level design or this high level decisions and patterns when it comes to work with variables and scopes. Mm-hmm. And that is that in the software computing discipline, we have now for security this concept of list of privilege, which guarantee now that your program are now that the access of your programs are only based on this least amount of rights. This is for high level design. Okay, this is for high level decisions in architecture overview. But in the case of programs, okay, or in the case of low level features, all right. Mhm. So in the case of low level variants, now the principle of least exposure when it comes to work with variables and scope is important because if you define now, it's important for a couple reasons because you can avoid an entire classes of bugs. For example, it's like naming collisions, unexpected behavior, and unintended dependencies. Mhm. Principle of least exposure, as applied to variable function scoping, essentially says default to exposing the bare minimum necessary, keeping everything else as private as possible. Declare variables in a small and deeply nested of a scope as possible. Rather than placing everywhere in the global or even outer function. So instead of putting all of your functions at the global scope or at the function scope to share across all of them, from the security standpoint, okay, so for the security standpoint of your applications, so expose at least to your program to eliminate an entire classes of bugs. So, for example, unintended dependencies or unintended behaviors and name collisions. Mhm. So, in other words, is wrap them into a block and define variables that you might need to work with them. And do this, for example. So consider the difference here. G and X and G, if X is greater than G, hold this in a temporal value, in a temporal variable, and then now reassign the new value and reassign the G with this value to be the greater, and G will be now the temporal, which will be is the lower. And then return now is the greater, the difference of that. But exactly, and then return now is the difference here. So no matter which difference is, give me is the difference here. The difference among these values here. Another way to do this, right? Another way to to get the difference between the two values here, all right, is by using also is a function here. No, don't come with that. Okay, much better. uh, which works great, but the also is to say, hey, if x is greater than g, which is two variables, you can say, hey, I do want to get is the difference between them. This is not rely on the logic. I do want to get is the difference between them. And to get the difference, you can is transform each one of those values as an absolute and then diminish it, right? So in other words, if you do want to have is what is the difference between is so for example is negative values and 5. This of course if you do now the absolute values, well, it will give you now is unfortunately 2. All right, so that might work for any positive values. If you want to get the difference from that, it will work is for positive values. So in this case, this also must work is for negative values. All right. So in other words, this must give you is 7, 5, 4, 3, 2, 1, as well as 0, and then 5 numbers are above, which is 12. And it gives you that answer properly. So my solution, that's interesting. That's interesting. So my solution with using is the math dot floor or the math dot apps absolute value and say, hey, what is the difference between this and here? It will give me 2 because I'm doing a transformations and putting all of this in the same unit, in the same level, in the same ground, right? But this is not what we want. This doesn't work. Again, this will work is for positive values. Makes a lot of sense. So my logic there will work for positive values. That's interesting. That's okay. So if you do want is to now truly get the difference of this value, you must somehow is to find out which one of them is the greatest number, all right, from this realm of from the realm of real numbers, right? You do want to get is that what is the bigger value here, and what is the you want to know what is the greatest value and what is the lowest value, all right? And then you're going to get is the difference from that, right? The difference from that. So if for some reason the first value you receive is this on this scale, and then the other value is this, you want is to now is somehow is to find that out which one is the greatest, right? Which is exactly what's doing here. So if you want to spot the difference here on X and G, all right, if you do want to spot now is the difference amongst them, you do want to say, hey, if I just want to figure out which one of you is the greater, the bigger, right? So if X is greater than G, all right, well, it means that we need to hold this X as the greatest value to call this as we can call this great value or bigger value, all right, as this, instead of holding this into a temporal variable because this is not descriptive. I really hate this, doing that. It's like, what the fuck is temporal? Now I'm holding this in a temporal value. No, be descriptive, please. So let bigger value is this, all right? And then, so now that I have this bigger value, I do want is to know is know the difference here, and know the difference with the least value here. So in other words, you might say something like this, all right? And if you do this, by holding this, or in this case, is just redeclare this as it is. Hey, now this is the bigger value, and G is the smaller value. All right. As G, you can also define as this smaller value. All right. So if this is the case, good, do this. This is just to spot is the bigger or the smaller value. If it's not, all right. If not, then you say, well, now the bigger, because this includes that. This is excluding that value. Okay, if both of them are the same, all right. No matter which one of them happens occur. So if one of them are the same, the bigger value will be equal here, and the smaller value it will be now this, so it doesn't matter here. Because at the end of the day, what we're gonna do is to subtract those amounts. But if for some reason now x is less than that, the bigger value is G, and the smaller value is this, right? And then what you're gonna do is just to subtract them. You say the bigger value minus the smaller value, and then you get is the difference, right? You're gonna return is the difference. So for example, if you do this, say diff, and you pass now -7 and 5, all right? It will now give you this. A little bit verbose, yes, but very much more descriptive of what the French toast happens here. So I don't need to actually try to squeeze my mind to understand what was the intent of the author was. So yeah, so it also is to make even the code a little bit cleaner. You can say something like this. No, like this. Must be like this, right? So this is the case I'm presenting here. This case is for readability here. It's for readability. And this also now caused me some issue because I must do this. Because when I do this, I say, okay, this is now a function scope, not block scope. So I remove an entire, it's just for semantics of the user semantics. So here we are, right? So we got this. So if this function, we want to ensure that G is greater than or equal to X, so that we subtract G minus X, the result is 0 or larger, okay? If X is initially larger, the result will be negative. So we sub the X and G using the temporal value to keep the result positive. In this simple example, it doesn't seem to matter whether the temporal is inside the if block or whether it belongs to the function level. Certain shouldn't be a global variable. However, following is the POL principle, the temporal should be as hidden in the scope as possible. So we block the temporal using let to the if block. Hiding in plain function scope. It should now be clear why it is important to hide our variables and function declaration in the lowest, mostly deeply nested scope possible. But how do we do so? we have already seen the let and counts keyword, which are block, scopes, declaration. We'll come back to them in more detail shortly. But first, exactly, hiding in plain function scope. I will leave this as it is for this moment. All right. But that'll be all for this video. Take care. Bye bye.